Hello again and welcome to another chapter of our networking course. Today we will be talking about subnets and VLANs. It is an important component of networking because nowadays, with the emphasis on cybersecurity, network performance, and ease of management of all the networking aspects of our enterprise, it is critical for us to understand the two concepts that we are going to touch upon today, which are subnets and VLANs. So we are going to get into our presentation in a second. So let us bring the PowerPoint presentation that we have prepared for this important subject that we are going to discuss today. So the topic that we are discussing today is subnets and VLANs. As you can tell from the topic for today, these are two concepts that are typically confused by many people, and it is important for us to explain what they are and what the differences between subnetting and VLANs is. The learning objectives for today are as follows. Why should we segment a network? That is an important question that we need to answer. What are subnets? That is the second question that we will be answering. And what are VLANs will be the last question that we will be answering today. So the question that we are asking ourselves right now is to segment or not to segment our network. And the answer, of course, is the earth is not flat and your network shouldn't be either. Why do we say that? Because if we take a look at the picture here on the bottom section of the slide, we will be taking a look at how we can segment our network, and we can do it with this diagram by just using two different segments within our enterprise and making sure that we understand why we are doing this. So if we create two segments depicted here, one in light green and one in light blue, we will be isolating or separating some of our users, some of our computers, some of our printers, databases, files, servers in one segment, the one on the left, and then separating them from another set of users, computers, printers, databases, and files that are listed here in this section in light blue under network segment number 2. Now, how do we control the data transfer or the network traffic between these two segments? We control the network traffic via the network firewalls that are depicted here, 1 and 2. Now, it could be that network segment number 1, which is depicted in light green, is our high security segment within our network, meaning the data that we are keeping on these servers that are part of network segment number 1 is highly confidential, and we do not want any external entities to network segment number 1 to be able to read or to access the data. So the firewall will be playing the role of the police cop that is controlling the network traffic that is coming in, all the network requests that are coming in to this segment, and making sure that only the people that are allowed to see and read the information that is considered highly confidential for network segment number 1 is kept confidential, because the firewall will do the investigation of the requests that are coming in and making sure that nothing is allowed unless the company policy and the firewall rules that we set up on this network firewall are telling us that yes, it is okay for us to grant permission for the request that is coming from the outside to read data that resides in network segment number 1. And network segment number 2 could be a lower security level section of our network, and this section could be also maintained by the maintain as far as security by the firewall that is set up right here that I am pointing at. So all the network traffic between these two segments will be controlled by these network devices that we call network firewalls. Now, as far as the definition itself, network segmentation is splitting a network into subnetworks. For example, by creating separate areas on the network which are protected by firewalls configured to reject unnecessary traffic. So this is a great definition given to us by NIST, which is the organization, the government organization here in the US that provides the guidelines and the standards for the implementation of technology in a very secure manner. So we are following this definition and implementing this definition, or providing a depiction of the definition in this figure that I am pointing at right here on the bottom of our PowerPoint slide. So the benefits of the network segmentation are as follows. It provides damage control and limitation in case of a cyber incident by reducing the size of the attack surface. So if a cyber crime actor is trying to access data and create damage within our company, and let's for a minute, let's think of our company as the combination of network segment number 1 and network segment number 2. If the cyber attacker is trying to create damage for our company, if he's able to access one of the servers in network segment number 2, he will not be able to create damage in network segment number 1 because there are two security controls that we have placed in between the two segments, and those are the two network firewalls that I am pointing at right here. So the cyber attacker is able to get access to this server that I am pointing at right here in network segment number 2, and he can perhaps create damage to other devices that are in the same network segment number 2, but he will not be able to get into network segment number 1 as easily as he will be able to move here in the light blue section. So we are reducing the number of impacted devices and impacted network surface within our enterprise by allowing only the damage to be isolated in this network segment. We also benefit from network segmentation by improving performance with less congestion on network traffic. Why? Because the network traffic that is dedicated to network segment number 2 stays within network segment number 2. Is not allowed to go to other sections of our enterprise, like for example network segment number 1, unless there is a good enough reason for the traffic to go out of the light blue section that I am pointing at right now. So by isolating the traffic to the areas of the network that are in absolute need of that data traffic, we are improving the overall performance of our network. And finally, the last benefit that we are describing here is the endpoint device protection. Now, more than ever, with the increase in IoT and mobile devices, IoT being the Internet of Things, and mobile devices, we want to make sure that we create segments within our network so we limit the number of devices that could be impacted in the event of a cyber attack. So if we are picturing network segment number 2 as a segment that is dedicated to the Internet of Things devices that we deployed in our network, we are going to create a specific security policy within our switches and routers and firewalls in this segment, so the Internet of Things are protected and they don't touch any of the other devices that we may have on our network. Some examples of the network zones that we can implement within our enterprise include the following. Imagine that we select network segment number 2 as the placeholder or the home of the users in our company. So we can segment by user population. And if we can go even further by saying it could be the users within the finance department under one segment, and then the users of the human resources department under a different segment, and so forth. Another way to implement zones within our network would be to divide one segment for guests of our enterprise, meaning vendors, customers that may be visiting our building, our company building, will be part of the guest network, different from the one that is used by the employees of the company that may be located in the light green section under network segment number 1. Now, just a disclaimer for explanation purposes and to try to make it easy for us to understand the concepts, we are dividing this company enterprise in just 2 segments, network segment number 1 and number 2. However, as you can imagine, within an enterprise you can have as many segments as you want and as you need based on the configuration that you want to implement within your network. Next, we have creating network zones for IT workstations. So you can separate workstations, by that I mean laptops and desktops, in one segment, and then dedicate the other one to, let's say, servers. So we can do servers versus workstations. We can also do voice over IP in one segment and data on a different segment. So voice over IP, which is typically a different type of quality level that you want to assign to the conferencing needs of your company versus the data transfer that takes place within your company, could be divided into 2 different segments. IoT and mobile devices, we talked about that. Creating a segment or a container that is dedicated to IoT and mobile devices will be another way, another approach, another strategy for implementing network segments within your company. And another one could be the industrial control systems, or IVC, and the example is your HVAC system that you may have within your company buildings, providing the air conditioning and heating system for your company. And finally, customer client environments. By that I mean databases that are dedicated to specific customers of your enterprise. So if you are a sales company, for example, and you have databases that are dedicated to each of your customers, you may want to have a light blue section for customer A light green section or segment for customer B, and so forth. So the data that belongs to your clients, not to you, but to your clients, is isolated from all the other clients that your company may be servicing. Subnets and VLANs. This diagram here will be an important one for us to review a little bit later. But first, let us define subnets. It can be defined as a logical subdivision of an IP computer network. Subnets are layer 3 constructs. Then this is an important concept that I want to make sure that you remember and understand. When we are talking about subnets, we are talking about a construct at the layer 3 of the OSI model level. Subnetting involves taking a network and dividing it into smaller subnetworks. An IP address has 2 components, the network address and the host address. If you take a look at this IP address given by 150.215.17.9, we are making the arbitrary decision of dividing this in 2 sections. The blue one will be the blue section of the network address, and the red will be the section dedicated to the host address. Subnet mask is a 32-bit number created by setting host bits to all zeros and setting network bits to all ones. Next, we move to the second concept, that is the important concepts that we want to understand today, and that is VLANs, virtual LANs. You can use VLANs to divide the network into separate logical areas at the layer 2 level of the OSI model. So important difference here, subnets work at the layer 3 level of the OSI model, and VLANs are constructs that work at the layer 2 level of the OSI model. VLANs can also be considered as broadcast domains. A VLAN is a group of end stations in a switch network that is logically segmented by function or application without regard of the physical location of those users and devices. VLANs have the same attributes as physical LANs, but you can group end stations even if they are not physically located on the same local area network segment. VLANs divide switches, the network switches, the physical switches, into virtual mini switches. You can create mini compartments, logically create mini compartments within one single piece of hardware, in this case, a network switch. VLANs help you extend the virtual mini switches to multiple switches. And for this, we are going to, for these definitions, we are going to use this diagram here, and we are going to see that this is the depiction of a building. Okay, so this is the third floor of your building, the second floor of your building, and the first floor. So this section is the first floor, this section is the second floor, and this section is the third floor. Now within each floor you have members that are part of the green section, that is the finance department. On each floor you have members of the orange section, that is a representation of employees and devices that belong to the HR or Human Resources Department, and the light blue section depicts members of the IT department within your company. And they are again spread around the 3 different floors of your company. So you have members of IT on the first floor, members of IT and devices that belong to IT on the second floor, and the same applies to the third floor. The same example can be used for human resources, the human resources department within your company, and you have human resources employees on the first floor, on the second floor, and on the third floor. So you have all your employees spread around your building, and you have them on different floors belonging to different departments. So you want to create a VLAN section for your finance department, and it is a logical representation of a subdivision of your network, and you are making this representation visually available to you by placing a circle or an oval figure within the users that are part of your finance department, and it is this section in light green. And even though you're traversing 3 different floors, first, second, and third, they are all part of the same VLAN structure that you created for the finance department. At the same time, this VLAN is associated to subnet 10.0.3.0/24. If you go to the VLAN 4, which is the light orange, you will see that this belongs to the Human Resources Department, or HR, and the subnet associated to the VLAN number 4 is 10.0.4.0/24. And the same applies for IT. The light blue is called VLAN 5, which is the logical representation of this subnetwork, and the subnet associated for that is 10.0.5.0/24. So that was the application of VLANs and subnetting at a company level, and combining the 2 concepts, one on layer 2 of the OSI model and the other one on layer 3 of the OSI model, layer 2 being the VLANs and layer 3 being the subnets. Now we talk a little bit deeper about virtual local area network, or VLANs. So we use them to separate and isolate traffic. We also want to reduce the broadcast traffic with the use of the VLANs, or the implementation of the VLANs on our network. We can use the following syntax on a Cisco switch to create VLAN number 3, for example. So if we get the prompt of switch number 2, in this case depicted by SW2, if you are in front of your terminal on a Cisco switch, you will see SW2 if that is the name of your switch, in this case referring to switch number 2 on your network. And if you type in configure terminal, then you will be able to get into configuration mode for your Cisco switch, which is depicted here on this line, and you will be typing VLAN number 3, assuming that that is the number that you want to assign to the VLAN that you're creating. So you type in VLAN number 3 and you get into VLAN mode, and now you can create a name or assign a name to that VLAN. It's not mandatory, it is optional. However, it is a good idea to assign names, not only numbers, to the VLAN, so it is easy for you to identify why you created the VLAN and who is part of the VLAN. So in this case, you created VLAN number 3, that is the numeral that you are assigning to your VLAN, but at the same time you want to assign it a name that is easy to understand. In this case, finance VLAN will be the name that we provide to this VLAN that we are creating. Then we exit the VLAN section of the configuration and we get into assigning ports on our switch for VLAN number 3, or the finance VLAN. And we do it by selecting port 24 on our switch, which is this line here that I am pointing at. So we are selecting port 24 and we make that port on the switch an access port, meaning it is going to be used to connect endpoint devices. It could be a workstation, it could be a laptop, it could be a printer. So it will be an access port on our switch, and port 24 is dedicated to now VLAN number 3. So that is why we say here switch port access VLAN number 3. So that port will be configured to go to VLAN number 3, and then we exit. And of course, this quick configuration will allow us to use port 24 for VLAN number 3, and we are saying VLAN number 3 is dedicated to the finance department. So here, if we take a look at the diagram on the right, let's see if we can do that. Okay. So if we take a look at the diagram on the right, we are depicting 3 different locations for our company. Okay, so we are saying, and let me make this red, for example. We are saying location number 1 is Houston. Okay, and let me make this a little bit easier to see for you. So we're going to go back here, and we are saying this is our first location, Houston. Our second location is Miami, and our third location is New York. Okay, so 1, 2, and 3. We have 3 different locations across the US that has offices of our company, the enterprise that we are working for. So we have employees in Houston, we have employees in Miami, and we have employees in New York City. So the users or employees and devices are depicted in these boxes right here. So you have users and devices here in this box, users and devices here in this box, users and devices here in this box. Okay, for this example, we are going to pretend that we are dealing with only 2 VLANs, 2 virtual local area networks, and one will be the one in green. So this could be, the one in green could be VLAN number 3, and the one in red could be VLAN number 2. Okay, so if you take a look at the red in Miami, we can set up all these switches that you see here on your switch and assign them to VLAN number 2, which is in red right here. And the same could be done in New York. We can configure these switches that I am circling right here as part of VLAN number 2, because the red is VLAN number 2. So even though these devices are in 3 different cities across the US, New York, Miami, and Houston, if you take a look at one of your network switches, which is depicted right here, I can configure all the ports that I am highlighting here, or that I am circling here in red. I can configure all these ports under VLAN number 2, because red means VLAN number 2. Now, how do you configure those ports? You will be following the approach that you see right here in the commands that you're typing on a Cisco switch, for example, to assign each of these ports to VLAN number 2. And VLAN number 2 could be finance, it could be IT, it could be human resources if you go by department. So what does that do for you? Why would you do that? You would do that because you want the data traffic that is depicted in VLAN number 2, which is the red, to be secure. So you are allowing for that data traffic to only traverse this section here. So the data traffic between the red blocks is isolated from everything else in green. That is why you are creating a VLAN that is traversing 3 different locations or 3 different cities within your enterprise, because you want to limit the traffic that you are sending between the users that are part of your finance department, assuming the red is finance, to this section of your network that is configured for VLAN number 2. So that is one of the reasons why you are creating a segment on your switch that is dedicated to VLAN number 2, by configuring the ports that are right here that are going to be part of VLAN number 2. So let me quickly so if we are saying that this section here is VLAN number 2, then all these ports here will be communicating only with these ports here and with these ports right here. So the only traffic that will be allowed will be between these ports, even though it is configured in 3 different devices in 3 different locations. So again, this is giving you the ability to isolate network traffic for security purposes and also for performance enhancement, because the traffic will not be traversing to ports that are not in need of that network traffic. Only the data that is going within employees or members of the finance department is the only ports that are in need of that particular data. So this is a very important component of understanding VLANs, and that is why I wanted to make sure that you had a visual that allow you to understand why we are creating VLANs. So then we will be talking about classful IP addressing and comparing that with classless interdomain routing, or CIDR. So for classful IP addressing, we can say that the IP version, and let me just make sure that I remove some of the notes that we placed on our screen so it's easier for you to see. For classful IP addressing, the IP version 4 addresses, which uniquely identify a device on an IP network, are 32 bits in length and are typically communicated in a format known as dotted decimal. So we know about that because we have been looking at different IP addresses all along. The 32 binary bits are divided into a network portion and a host portion. We talked about that as well. The IP addresses are split up into several different categories, including, and this is where we need to introduce the concept of class A, class B, class C, class D, and class E. So for class D and class E, we are not going to spend too much time because class D is reserved or associated with multicasting, and class E is associated with the reserved IP addresses that are set by the configuration standard for IP4 version 4. So the only ones that we need to worry about for now is class A, B, and C. And what are class A, B, and C? So for class A, we are seeing that the first octet of the IP address is the network portion. Everything else is the host portion. So that is depicted here. Class A IP addresses, the first octet is the network portion, and the last 3 octets are the host portion of the IP address. For class B, which is depicted here, we have the first 2 octets are the network portion, right here in orange, and the last 2 octets are the host portion in class B IP addresses. And in class C, the first 3 octets are the network portion, and the last octet is the host portion. So that is the classful IP addressing scheme. Now, we moved into classless interdomain routing, or CIDR, because it is a method for allocating IP addresses and for IP routing. It was created to two things: slow the growth of routing tables on routers, number 1, and number 2, help slow the rapid exhaustion of IP version 4 addresses. We were running out of IP version 4 addresses. So those were the 2 reasons why we implemented classless interdomain routing, or CIDR. Whereas classful network design for IPv4 sized the network prefix as 1 or more 8-bit groups, and we see that here, resulting in the blocks of class A, B, or C addresses, which again we saw earlier today. Under CIDR address space, the allocation is given a little bit easier and more freely, because we are able to use any address bit boundary. So we are not restricted by 8 bits boundaries to create different sections within our network. So we can create a /32, /31, /30, /29 by assigning different bits to the network side of the equation and giving a different number of bits to the host section of our IP addresses. So if this is the binary notation of an IP address, you see the first octet right here, the second octet right here, the third octet right here, and the fourth octet right here. So this will be /32 because all ones are part of the IP address. But if you remove one of the ones and make it a 0, then you have a /31. If you remove 2 of the ones and you make them zeros, now you have a /30, and so forth. If you continue, if you remove 3 ones and make them zeros, this will become the host section of your IP address. Then it will be a /29, and so forth. Now, the more zeros that you assign to your IP address, the more available IP addresses for your nodes that you will have. So as you can see, the number of zeros is increasing. This is the host address space, and the number of available hosts that you can connect to that particular subnet is also increasing. You start with 1, then 2, 4, 8, 16, 32, 64, 128. These are the number of available IP addresses per subnet. If you go with a /24, you can create, you can have 256 IP addresses in such a subnet. And the lower you get into the CIDR notation, the more number of IP addresses you can assign to those particular subnets. Subnetting is dividing one network into smaller pieces. Some important reasons to subnet are, we talked about, easier management. So as a network administrator, you will have an easier time managing the overall network if you divide it into smaller pieces, because now imagine yourself bringing the concepts to life. Imagine yourself that you have a network with 20,000 employees or 20,000 nodes. It could be a subset of employees, a subset of printers, a subset of computer devices, but altogether you have 20,000 nodes on your network. So imagine managing that as a bulk, as a unit, 20,000. It will be easier if you can divide it into smaller pieces, so you can create different configurations for each of those smaller pieces, making your job of managing the network much easier. So that is one of the reasons. The other one is network security. We talked about creating different subnets or different zones within your network, and one of them will be the highly confidential or highly secure zone or segment, and the other one will be the medium level security zone, and the other one will be the lower level security zone. So network security will be one of the drivers to do subnetting and dividing your network into smaller pieces. Also better performance, because as I showed you in the previous diagram, if you divide your switches into VLANs, into subnets, you will be able to control the traffic that is needed only for that segment of your network to go to the ports that are configured for that particular subnet or for that particular VLAN. So better performance is realized with the subnetting. So this is one example given 192.168.10/24. This is the CIDR notation of this IP, of this network, of this segment of your network. Then what can you do? So if you divide this in bits, you have the .0 to .255 right here, and you have /24 means all of this is one network. All of this space, network space, is one network. Now, if you decide to divide this large space into two segments, you can apply the /25 approach and divide it in half. The first half will be from .0 to .127, and the second part will be from .128 to .255. So this will be dividing a long /24 network into two pieces, and that will be the /25, and you have two segments that are /25, or two subnets that are /25. Now, you can also divide this large section, the /24 network, into four equal pieces, and those are depicted here on the bottom. You have one section or one segment or one subnet, and you will be using the /26 because you are dividing this in four, and the space, the IP space that is associated with a /26 in this example will be given by IP addresses that are from .0 to .63 for the first subnet. So in the example of the IP address or the network segment that we are depicting here, it will be 192.168.1.0 will be the beginning, and the end of this first subnet will be 192.168.1.63. So that will be the end of the first subnet. Going back to the example, if the space that we are dividing into four, which is this space right here, The second segment or the second subnet will be from 192.168.1.64. That will be the beginning of your second segment, and the end of the second segment will be 192.168.1.127, because that 127 is right here as the end of the second segment. The beginning of the third segment will be 192.168.1.128 as depicted here, and the end of that third segment will be 192.168.1.191, which is this number here. And the last subnet that you are creating with the /26 will be 192.168.1.192. That will be the beginning of that subnet, and the end of that subnet will be 192.168.1.255, which is the last IP of that subnet. And you're dividing this large /24 network into 4 equal pieces that are depicted by these /26 subnets that you have here. This marks the end of this important chapter of our review of networking, the one that we dedicated to subnets and VLANs or virtual LANs. I am planning on providing a quick summary of how to do subnetting using a quick way of implementing subnetting on a piece of paper, so you're able to do some of the calculations rather quickly if you're planning on taking one of the networking exams that will become an important tool that you can utilize, and it will become really something that comes in handy for you when you're taking the exam and you need to do some of the subnetting calculations. For real work application, you will see that subnetting is not really done on paper, and there are multiple websites that you can access to do all the calculations for you, as long as you input some of the requirements of your company, meaning how many sections, how many segments on your network you are planning to create, what is the IP address space that is allocated to your company, the large one in the example here, the /24 could be the space allocated to your company, and now you need to divide it into 4 pieces. So you enter those criterias onto the website and you say, I want this IP address space to be divided in 4 or in 6 pieces, and give me all the calculations as far as what is the beginning IP address, what is the end IP address, and what is the subnet mask for each of those subnets that I am planning to create. And the website will give you that output automatically as long as you are entering the criteria or the requirements for your company. So as far as the real world application, there are many automated tools that you can use to create your subnetting. However, if you're planning on taking the exam, the way that I am going to show you in the next video as far as how to do subnetting will be an important tool that you can utilize to create or to do all the calculations for subnetting rather quickly if you're planning on taking the exam. Thank you very much. Until next time.